Hi, everyone. Welcome to Columbus State Television and Twiss. This week in space science, I'm Michael Baltimore, your host, and I'm here with Dr. Sean Cruzen. Sean, how are you?
I'm good, Mike. How are you today?
I am fine. Happy to be here.
I'm happy to be here too.
Exactly. In the studio here in Jordan Hall at Columbus State University. And each week we bring you This Week in Space Science because Sean Cruzen, Dr. Sean Cruzen, is Executive Director of the Coca-Cola Space Science Center here at Columbus State University, downtown, Front Avenue.
Yes, sir.
And what a wonderful place you have down there.
Thank you. I very much appreciate it.
It is an amazing place. And of course, if you're a kid in school, you probably had a visit down there at some point or another.
Yeah, you know, if, we handle schools from all over the southeast region, but if you're right here in Muskogee County, every sixth grader in the local school district comes through in the course of a school year.
Every sixth grader?
Every sixth grader, and has an experience in our Challenger Learning Center and with activities throughout the exhibit gallery and in our planetarium as well. So, yeah, if you're in the area and you were going through the elementary school system, you probably come down and had some adventures at the Coca-Cola Space Science Center.
You know, I bet every kid is really excited and energized when they get there, and just to learn all of the things, because you guys put them on simulated space flights, right?
We do. We do a simulated space mission in Georgia's only Challenger Learning Center. So in addition to that, though, we have just a variety of artifacts for them to see at the Space Science Center. Also, flight simulators and a bunch of fun hands-on activities.
That's what I was thinking.
Our exhibit gallery.
Yes, and the hands-on, that's got to be important for the kids because they want to learn and they want to have their hands on all of those controls, right? All right, that sounds really good. Well, each week we bring you information about what's going on in space and certainly space science. And so I noticed today that we have a couple of topics.
Yeah, there's a couple of interesting things that are going on this week, and one has to do with more space science and space exploration kind of topics. The other one has to do with some astronomy and some astrophysics, and we're going to get to that second.
All right, because I think there's something about stars in there.
There is indeed.
A sun and
the true
stars.
Nature of stars.
I love it. One of my favorite topics, so I can't wait to get to that. Oh, okay. You got some. You're going to do a reveal here on the show
so,
today.
Maybe so.
All right, that's really good. All right, so go ahead and start us out. I see on our list that we have the famous company now, SpaceX.
Well, so we're going to talk about SpaceX again, and SpaceX is a bit famous, and one of the reasons they're a bit famous is because they are the ones that are doing a lot of the heavy lifting in terms of our America's space program, taking both payloads back and forth to the International Space Station, and also working on eventually taking astronauts back and forth into low Earth orbit. So, but they're doing more than that. They're actually developing rockets as well that would be able to leave Earth's gravitational field, get outside of that, and travel to some deep space locations as well. So we have a whole menu of items to be able to talk about with SpaceX. But the really big news, the thing that's going on right now, is that SpaceX has successfully test-fired their Falcon 9 rocket engine, which is sitting on a launch pad at the Cape Canaveral Air Station right next to the Kennedy Space Center in Florida. And they're doing that rocket test launch in order to be able to make sure all systems are go for an upcoming launch to the International Space Station, another cargo mission up to the International Space Station. Now, here's the thing I found out just literally a few minutes before we went on air.
Okay.
Right here, you're seeing some photos of that successful test launch that took place what is now last Saturday, March the 8th, 2014. After that test firing, however, they found some oily substance on the inside of the Dragon capsule. Now, where you would find that is up here on the top of the rocket in this picture, inside what's called a cowling, and a cowling is basically just the covering on the top of the rocket. That's where the payload sits, and inside that cowling then is a layer of thermal blankets, insulating blankets that are around the actual payload-bearing capsule that we call Dragon. The oily substance was found on those blankets that are surrounding that capsule.
Okay.
They think it may have even penetrated inside the capsule and perhaps maybe even contaminated some of the payloads. So they said, well, look, we can't launch this weekend, which is what their intention was, which would have been the 16th of March, 2014. They're going to delay that till the 30th of March. So they're going to give themselves a couple of weeks to be able to open that package up, that payload package, and make sure that oil leak, whatever it was caused by, number one, they want to know what it came from.
Absolutely.
And number two, they want to know if it leaked inside and caused any damage to the payloads that are inside the capsule. So a couple of things that might delay them slightly, but the rocket itself tested positively. It looks like it's good to go. They have emphasized that there's no system malfunctions with either the capsule or the rocket that will take the capsule into orbit. So those things are all good to go. Just got to give a quick check to the payload, and they should be ready to launch on the 30th of March. So we'll be looking for that payload to go to the International Space Station here in just about 2 weeks.
Now, they've been to the space station before.
They have.
Okay, that's something. And by the way, just the cost of that sounds rather extreme, but who pays for that?
Well, so that's...
And how does that work?
So NASA has taken a portion of their budget, and instead of flying their own space shuttles and paying for that rather expensive and somewhat cumbersome launch system, because cumbersome in the sense that it was so complicated to get it back and forth to low Earth orbit, they're going with a much simpler, much less expensive system from SpaceX, and they're paying SpaceX via a contract to launch these payloads back and forth to the International Space Station.
Okay, so that's helping SpaceX, but it's also a budgetary, probably a good decision on a budgetary way as well. So SpaceX is really doing a lot of work these days. I mean, it seems like they're always in the news, something's coming up. This company is moving very fast and forward in an amazing way.
They are indeed, and remember, before we get off that topic of the budgets too far, remember that we have lowered the costs for these trips for cargo back and forth to low Earth orbit, but we can't carry astronauts, right?
Right.
So that's the trade-off, is that we can no longer carry our own astronauts back and forth to space. That's what Shuttle was doing, and now we're having to outsource that to the Russians with their Soyuz system.
Right. I remember we talked about that.
Yeah, it's
before,
a bit of a disadvantage.
Russians, yes.
But you're right that SpaceX themselves are moving forward with leaps and bounds, and what they're trying to do is they're trying to get their Dragon capsule rated for human spaceflight. And if they get that capsule rated for human spaceflight, what that's going to allow them to do then is, on this very same system on which they're currently hauling cargo, they'll be able to take astronauts back and forth to low Earth orbit destinations like the International Space Station. And that will truly be a big leap forward for both SpaceX and for NASA, because then American space astronauts can ride this American space system back and forth to space, and that's going to be a big step forward. Okay,
all right, that sounds good. I know, continuing along the lines of SpaceX, you talked about the Dragon.
Yeah, so the Dragon capsule is preparing, SpaceX is preparing to do something interesting with their Dragon capsule, which is plan a mission to Mars at some point. They have a system which they're calling Red Dragon, which is a modification to their Dragon capsule. And basically what they're going to do is they're going to provide some onboard rockets for the Dragon capsule that it would allow it to do what's called a retro-fire landing, which means it's firing rockets down and this thing can come down and land on the surface here.
Okay.
And so I think there's an artist conception photograph of the Red Dragon here. And we can see what it might look like if that modification was made and it was coming down to land on the surface of Mars. And this is it. So again, this is not a real shot, obviously.
I know, it looks
There are no
real,
photographers on Mars to take this picture.
Right, no, sorry.
This is an artist conception, but as you said before we went on air, this is actually a really good artist conception. It gives you a very good idea. You have to pause for a moment just to figure out if it's a real photograph or not.
Yeah, sometimes when these artist conceptions come out, you don't see the use of shadows and the light and the reflections and so forth, as you do in this one on the side of that capsule. So it does look quite real.
Seems to be pretty good, actually.
But that's a nice idea. So those rockets fire out and then kind of in a diagonal pattern.
That's right. And so they allow then for that spacecraft to slow down against that Martian gravity and come down to a safe landing. But here's the interesting thing about the concept for Red Dragon. Not only could they use those rockets to land, they could also use those same rockets again, and those rockets can provide enough boost for that craft to lift back off the ground.
Okay, all right.
And take off out of Martian gravity. Now that's a fair amount of thrust, but the interesting thing is SpaceX has already proven that concept. They've proven that they can build rockets that are capable of doing that, not only in the Martian gravity, which is actually less than Earth's, but they've done it right here on the Earth with a space system that they call the Grasshopper system.
Oh yes, we saw pictures of this one.
Grasshopper is a very interesting system. We did a show where we featured Grasshopper earlier on last year, and this is actually a shot of Grasshopper taking a very interesting flight on August the 13th, 2013. This system actually blasted off vertically, then paused and held itself in the air stably,
Right.
then moved sideways for about 200 yards, then came back down to the ground again. Now, there was a museum in New Mexico that took photographs of this event, put them into a sequence where they superimposed on the same photograph. And here is kind of, it almost looks like a time-lapse compilation of that rocket going through that process. So on the right-hand side, you can see it taking off, blasting off, going up into the air a couple hundred feet, then moving sideways, again, for about 200 yards, and then coming back down again and lowering itself down and landing successfully. So there's a test of an onboard rocket system that has not only the capability of blasting this rocket off, but also for providing that nice soft touchdown against the gravitational field of a planet.
And being able to move in the direction so there's a better landing site.
A lateral movement also.
Yes.
You're right. So rockets both powerful enough and stable enough, and the control system stable enough that it can hold that rocket and hover in place in the air, kind of like a helicopter would do, and move sideways, move laterally, find the best landing site, as you just stated, somewhere that's nice and level and flat, and be able to come down safely and land there. And then again, launch back into space, escape Martian gravity, rendezvous in orbit with some kind of a ship that then would take it back to Earth orbit, rendezvous with another ship that would then take it back down to the ground. That is called a sample return mission. It has never been done from the planet Mars. So all of the Mars exploration that's been done has all been via some kind of a robot or some kind of just a lander or some kind of spacecraft that's in orbit photographing the surface. Never has a spacecraft gone to Mars, dug around in the soil, gathered some samples from the Martian surface, lifted off again, and then come back to the Earth to provide those samples to the scientists back here on Earth, and then and able to do all of that from Mars. So that's never been done before. SpaceX has announced their plans to be able to have this system in place, Red Dragon system, and the Falcon 9 heavy rocket, which would be required to take it there out of Earth orbit.
Yes.
By the early 2020s.
2020?
2022 or somewhere in that venue, which is, that used to sound like a really long time in the
really
future
in the
to
future, but I don't think so. It's not that far
Not that
out,
far away now, is it? So it's only about 6 to 8 years away. So sometime between 2020, 2022, 6 to 8 years from now, you could have SpaceX developing the first sample return mission to the planet Mars. Now, the reason that that's very impressive to me is because no government has been able to get that done, right? So no entire nation with their wealth and all the scientists working for various space agencies have been able to accomplish that task. Yet, in the very short existence of the company SpaceX, it looks like they might have a system capable of doing it and be able to actually pull that off within less than a decade from right now. So that's an another amazing milestone feat for SpaceX.
I tell you, do not bet against Elon Musk is basically what this story is about, because that guy is moving at an alarming rate and he's making progress like never before. So SpaceX,
certainly true.
It's amazing.
Very interesting thing. One last note before we get off this topic of the International Space Station. The next Dragon mission to ISS, it's got a very interesting payload that they're planning on taking up to the International Space Station, which is a brand new mode of data transfer from the International Space Station to the ground and back. And that is, well, how do we get data? We don't have an Ethernet cable, that we can hook up to the ISS, right? They don't have.
We're not ready for wireless.
Wireless is exactly what they're doing in a sense.
So
they're going by radio right now. So that's a form of wireless communication. But those
not as fast as wired, I guess.
It's not as fast as the best wired, the optical devices, right? So the communication back and forth from the International Space Station to ground in terms of data transfer, they're operating at a data rate of about 400 kilobits per second. That's the current system right now. There's a new system that's going to be delivered to International Space Station that, if it works properly, and it was developed by JPL, already tested on the ground, and it seems to be working properly, but if it can work properly in the space venue, should allow them to bump data rates from ISS to ground up to 50 megabits per second. So that's a huge jump. They compared that jump in an anecdotal sense from like it's like going from dial-up to a DSL modem, right? So it's a much it's a quantum leap forward in terms of data rate transfers.
And so if they have experienced that.
That's
before,
exactly right.
Yes, that's a good analogy.
The system is called OPALS. It stands for Optical Payload for Laser Comm Science.
All right. Yes, I
go.
love these
strained acronym,
acronyms that are just all over. But yes, that does it.
OPALS. There it is. So anyway, OPALS developed by JPL, and if they can get it done and if it's working, it's going to use a laser beam to send light to a receiving station near JPL in California and be able to transfer that at a much, much higher data rate than those radio communication systems were able to do prior to that. So it's an interesting experiment. Can't wait to see it fly. So when Dragon takes off from Canaveral Air Station and delivers its next payload, that OPALS system will be among them, and we'll see if we can get the data rates on the ISS up a little higher. That way, the next time they want to watch a Netflix movie like Gravity or something, they can stream that a little quicker up there on the ISS.
Yes, streaming the Netflix to the ISS. I'm not sure. There might be some other things they want to do, but you know what it makes me think of
science
is
or something. They could do science or something.
We could do science, but well, there's a lot of good Netflix movies out there. But what I was thinking is this is to the ISS, but then that capability, once it's tested, could be used with satellites and for other communication. We could speed up a lot of things around.
That's exactly right. And of course, that's one of the famous aspects of what NASA does, is that they develop technologies that are then spun off for commercial use. And so one of the things that NASA gets some credit for, but in my mind doesn't get enough credit for, is developing these pioneering technologies like this laser data transfer system, and then that technology then exists for commercial use, and lots of money's made from the developments that started out as a science or technology project within NASA, something they needed to accomplish for the engineering or science mission for some kind of a spacecraft. It gets then parlayed into the private sector, and lots of money is made. And so hopefully this will be yet another one of those systems that helps people make money and stabilize our economy here in the good old United States of America.
All right, I like it, but you know, this entire show has almost been so far has been a SpaceX show, and we might need to reach out to Elon Musk for maybe sponsorship of Twiss.
Elon, if you're watching.
All right, there we go.
Columbus State University
That's not going to happen, but
needs you.
But we've been down this road, and I got to say, it's really worth reporting that SpaceX they're doing a wonderful job here. But let's move on to science.
Let's do.
All right, go.
Because something else that has come up this week in space science is the discovery of a very, very interesting star. It's a star that's in a super rare class of stars, and the most intriguing factor about these stars is they're just really, really big. They're called hypergiants.
Okay.
And the European Southern Observatory down there in South America that telescope down there has been able to discover what's called a hypergiant. And so this hypergiant is a star that's 1,300 times the size of the sun. So, okay, for perspective, let's go back. Our planet Earth, if we were to line up our planet Earth next to itself 109 times, that 109 Earths side by side would be the diameter of our own star, the sun. The volume of the sun is substantial enough that it could hold over 1 million Earths on the inside. So our star is pretty big. It's a very large star. And among all the stars, it's about in the middle or the median area of star sizes in general. However, when compared to this hypergiant, it seems rather small, because you could take our sun and line it up next to itself 1,300 times. And that would stretch from just one side to the other of one of these stars called a hypergiant, the one that they just discovered, which is known as HR 5171A. Now that was discovered by the European Southern Observatory. So here's the question.
Yes.
You know, the question is, what kind of a star is this? I mean, it's a freak star. We don't see very many stars in this category. And in order to really describe it properly, we have to talk some basic science about the way that stars work. And so one of the first things we know about stars is they can be various sizes, but they can also be various colors. And so one has to ask the question, well, why is a star one color versus another, or one size versus another? And so that leads us to some very basic star physics that we want to talk about. What a star really is, it's a very interesting machine. It's an extremely strong gravitational source that self-gravity is trying to pull its matter down to a single point. It wants to crush its own matter out of existence via its own gravity. You might ask, well, what is it made out of? Well, stars are mostly made out of the most common element in the universe, which is hydrogen. So you have a star, a tremendous collection of hydrogen, with its own gravity trying to squeeze all that gas down into just the smallest location possible. Well, here's the thing, Mike. When you squeeze gas down in a ball, the temperature increases.
Right.
When the temperature of gas increases, the pressure increases. And so tremendous pressures inside that gas want to blow that gas apart. They want to spray that gas back out into the solar system. So now you have two forces at work. You have that tremendous gravitational field squeezing inward. You have that tremendous pressure due to the thermal pressures in that gas wanting to blow that gas outward. Gravity in, pressure out, gravity in, pressure out. And what happens is that star settles down between those two forces into what's called equilibrium, a balance, a natural state where the pressure outward is balanced by the gravitational force inward, and you have a stable star. It's unbelievable that it can even reach that kind of stability the way our sun is, which only varies 1 or 2% in brightness over the course of hundreds of years, which is tremendously stable situation. So that's really what a star is. Down in the core of that star, you have the power plant for the star, which is under the area of greatest pressure. You can actually fuse hydrogen into helium, which releases energy, and that thermonuclear fusion taking place in the core is really the source of all the power, producing the pressure that wants to blow the star apart, which then ultimately balances gravity. So that's what a star is.
All right.
In the simplest terms I can come up with. It's a giant ball of gas with fusion taking place inside, gravity pushing inward, pressure pushing outward, and it all comes to balance and is held in a stable equilibrium.
Okay.
All right, so now, go ahead and ask me, what makes a star a different color?
Well, I was wondering about the color of stars because I just happened to see a chart that we're going to pull up in just a minute of the different colors of stars.
Stars can be different colors. Here's the very chart of what you were describing. If you look over on the left-hand side, you see those stars that are very, very blue. If you look over on the right-hand side, you see some stars that are very red. In toward the middle, somewhere a little bit to the right, you see stars that are somewhere between white and yellow. They're listed in classes with letters.
Yes.
Our sun is a G-class star, so you can kind of see where it falls on this spectrum of temperature. It's kind of not quite in the center, but almost. What we call the system of classifying stars with letters, we call it the Stellar Spectral Classification System. And it goes like this, O, B, A, F, G, K, M.
Sure.
Many sexist professors in the past have taught this as O, B, A, fine girl, kiss me. That's the way I learned it, but that's just because I'm an old guy. There are various other mnemonic devices that can be applied to remember this order. The order actually started out alphabetically, but then it was shuffled around due to some better understanding of some of the physical principles involved with stars. And now you have this spaghetti soup, which is difficult for intro astronomy students to memorize. O, B, A, F, G, K, M. Anyway, O stars on the left-hand side, they are the bluest stars, and they're blue because they're the hottest stars. So the ones on the left-hand side, they are the ones with the highest surface temperature. The red stars on the right-hand side, they are the ones with the lowest surface temperature. Now, in the most simple world possible, you would say, well, okay, then those O stars on the left, they must be the biggest stars because they have the most mass and therefore providing the most gravitation, driving up the most pressure and ramping up fusion the highest, and that's what causes them to be the hottest.
Sure, I mean, that's logical.
That is logical, and that is kind of the way it works for the majority of stars.
Okay, but
by the same argument, on the other side, you have these M stars, which are the smallest stars. They are the lowest mass stars. They have the weakest gravitational fields. Their gravity is squeezing down on their cores with the least amount of force. Therefore, they provide the least amount of pressure, the least amount of fusion, so they just don't make much energy, and so they're not very hot. And that's how that whole spectrum works. Stars, obviously, toward the middle, like our sun, they're average size stars with an average amount of mass, and they're producing an average amount of energy or a median amount of energy. and so therefore they're kind of in the middle of that whole arrangement. Okay? So blue stars, very hot, very big. Red stars, very cool, very small. Yellow and white stars, somewhere in the middle. That's the general continuum of star color. But here's the thing. Sometimes you can have stars that are very, very big, but they're also very, very cool temperature-wise. And so you have, they're red in color, but they're also just super gigantic stars in terms of size. Those are a rare breed, and they are called either the red giants or red supergiants. And they live off in their own kind of spectral bin, their classification bin. So they don't behave the same way the rest of the stars behave, so they get classified off by themselves a little bit. Okay. Another classification that can occur is what we call a white dwarf. It's tiny. So if it's tiny, it shouldn't be producing all that much energy and heat, but yet it is extremely hot. And so it's very small, but very, very hot. It's another weird star. It turns out it's the dead core of a star that has gone through its life cycle and blown off all its outer layers, and all you're seeing left is the core. Before it got to be a white dwarf, it was probably a red supergiant, because they're the stars that are going through the process of using up all their nuclear fuel and dying off, which is one of the reasons they expand. But the point being, the red supergiants, big red stars, and the little white dwarfs, super hot stellar cores, they're the oddities. They're not in the statistical norm. They're exceptions to the behavior. Well, the hypergiant star that was just discovered, as it turns out, is a yellow hypergiant star. And the weird part about this, so this is what makes the story have a mystery to it. Yellow hypergiants, they weren't even thought to exist. There are only a handful that are now known today. And this particular hypergiant is among one of the largest stars ever discovered anywhere. There's a star in the constellation of Orion that a lot of people know, especially backyard astronomers. They know it as the star Betelgeuse. Betelgeuse for a while was thought to be the largest star known. Then it got demoted to be one of the largest stars known. The yellow hypergiant that was just discovered by the European Southern Observatory is 150% bigger than Betelgeuse. So it's half again as large as Betelgeuse. So it's huge. It's this gigantic star, and so it really is an oddity, because it's not a red giant or supergiant. It's also not what's called a blue supergiant, which would be on the one end of that normal sequence of stars that we're talking about. It's yellow, it's in the middle. And it turns out that we really don't understand the physics very well of why a star would be that color and be that size. It's not a very well understood phenomenon. I've got something I want to show you, which is called an HR diagram. This diagram was developed by a couple of astronomers by the name of Hertzsprung and Russell. That's why it gets called the HR diagram. But it's kind of a plot. It's a plot of stars that allows us to look at the sequence of stars and talk about their physics and what takes place with them. And what you'll notice on this HR diagram, you'll notice that the majority of stars lie on a diagonal band that starts in the lower right and goes to the upper left. And what you have in the lower right are those M stars, the little tiny red ones that aren't producing much light. In the middle, you have the yellow stars like the sun. And in the upper left, you have those big O stars, which are the blue supergiant stars, which are producing all kinds of heat, of light and energy, because they're very, very massive, big stars.
Okay, so I'm sorry, tell us a little bit, before you go on, tell us a little bit about this chart itself. That is surface temperature at the bottom.
Yep, what you're looking at on the bottom axis, you're seeing the actual temperature of the stars. So all of the cool stars, cool in temperature, are over on the right-hand side, and that's why they have that kind of red color to them, to kind of show that. All of the super hot stars, they're on the left-hand side of that diagram, and so that's why they have that blue color to them. And then on the vertical axis, what you see is the luminosity, or the absolute magnitude, how bright they really are, how much light they're putting off. That's the vertical scale. So what you're going to notice about those stars that are down that bottom right-hand corner, they're not very hot and they're not very bright. The stars that are up in the upper left-hand corner, they're very, very hot, and they're also very, very bright. That's because their size is so big. Then you have that weird class that we called white dwarfs a minute ago, which are very, very hot, but they're not very bright. And that's because they're just tiny. They're really super hot objects, but they're very small in size. In the upper right-hand corner, you have stars that are very, very huge, giant in size, so they tend to be fairly luminous, but their surface temperatures are very cold in comparison to the rest of the stars, at least. And so they're very red in color. Notice that the star in the farthest upper hand right corner is Betelgeuse itself.
Right.
So we see Betelgeuse in that category where it's in the upper right-hand corner, not very hot, but super bright because it's so giant. Well, it turns out that hypergiants, the star that we're talking about today, wouldn't be anywhere on this main sequence, anywhere on this HR diagram. It would be off the HR diagram entirely. And I have another image that shows that. See if we can pull up, there he is, that last. This is the same kind of a plot. You can see what's called the main sequence, all the stars behaving normally. You see the red supergiants in the upper right, white dwarfs in the lower left. Way at the top of the diagram, you see this brand new category called yellow hypergiants. And they are on the top of this diagram because they are so much brighter than the sun. So the new star that was discovered, get this, it shines with the light of 1.7 million suns. That one star shines with the luminosity of 1.7 million suns. And that's why on that diagram that we showed before, it wouldn't even fit. We had to make a new diagram that the top of the diagram went up higher on the luminosity axis so we could even plot this star on there, and that's where it would live up there. So this is really a weird classification of star. Again, the physics behind it wasn't well known. When the astronomers actually looked at it and got some interferometric images of this with the telescopes in South America, they figured out that it wasn't just one star, it was actually a binary star. So it was one very large star with a small companion very close by. I think we have an artist's conception picture of that.
This is nice.
Here it shows the yellow hypergiant HR 5171A. Why do they call it A? Well, that's because there's a B, and the B is the companion star, right? So A and B. Off to the right-hand side, you see a blob sticking out to the right. That is actually a companion star. But notice these two stars are so close together that they're actually sharing material. The gravitational fields of these two stars, because they're so close together, are strong enough to pull gases from the surface of one star onto the other. And so they are sharing materials, and they're existing in this weird binary pair. But the one on the left-hand side, that's the yellow hypergiant. Again, you can line up the sun 1,300 times across the surface.
That is huge.
It is very big, and it's very weird, right? And so scientists now, astronomers are in this phase where they're trying to figure out, why does the star look this way? What is the physics going on? They have some models that they're using right now to try to explain how this star works and why it's in this phase. It turns out that when a star is reaching the end of its life cycle and it goes into that red supergiant phase, astronomers think that there is some instabilities taking place in the interior of the star, the core of the star, that cause it to both rapidly heat and rapidly cool. So you have very quickly varying surface temperatures, which drive it from being a red supergiant most of the time to, for a short period of time, jumping over here to being a blue supergiant, and then jumping back to being a red supergiant. Well, somewhere in the intermediate phase, it has to pass through that yellow or that median temperature region. It doesn't stay there very long. It's just maybe 1,000 years, which is on the life scale of stars, a very short time.
Sure.
And so it's kind of a transitional phase between a red supergiant and sometimes blue supergiant star. This has only been observed a few times. Astronomers aren't really sure that's the correct model, but that's the model they're going with right now. And that's what makes this discovery so interesting. It's actually seeing an object that is obviously very rare. We see it almost nowhere in our galaxy. Only 3 of these stars are known to exist. And so you could be looking at an ultra rare transition phase of a supermassive star that's about ready to go supernova, leaving a black hole behind. But before it does that, it passes through this weird transitional phase that we call a yellow hypergiant. And that's today's astrophysics.
Truly
very interesting object.
Off the charts, as we said, literally off the charts.
Literally off the charts, right off the top of the HR diagram.
All right, very, very interesting. Sean, thank you so much for bringing this information to us today here on Twiss, and we hope everyone is enjoying this show. We're here once a week, This Week in Space Science, right here on Columbus State Television. Stay tuned and watch us next week. For Sean Cruz and I'm Michael Baltimore. We'll see you next time.